Welcome back to Wickerson Studios. Michael Wickerson here, making a 15th video, which is just some data visualization, working on the second Grasshopper script for Numpy basics, array and vectorization into Grasshopper, and Rhino 3D geometries. And I thought I'd start with this pretty interesting one, partly because it's the smallest to start. I have something baked in here. It's pretty nice. I'm going to take the layer off and let you see what's happening here in this data visualization. And it's basically working with a 4 by whatever I want array. You see that this kind of plays off on making some decisions for me here as well. So it's a little tricky that it's the 4. It's just having trouble gathering the data because of the array if I keep it away from 4 by 4. So this is a little jumbly and you can kind of lose yourself in what's happening. But if you leave it as a 4 by 4 array and treat it as the I array, you can simply adjust this data from negative passing through the numbers. And this is the trick because you have to keep this activated while you hit your number sliders, which is a little pain in the butt. But if I slide this through, you'll see that I can actually start to take some off all the way down to the original 3, 4, then, sorry, minus 1, 0, 1, 2, 3, 4. So you're basically stepping through the data, and you're stepping through very quickly, driving it from, and if I put this down, you'll see exactly what that's doing to the data. It's generating these arrays as we go, and you can see that it's stepping down in one way to the one down in the bottom right corner, left corner, and then all the way up to the ones all the way up on the top right corner. And of course, that's driving the geometry that's then being output. I'll just leave it balanced in the middle of 1, 0, 0, 0, 0, 1, 0, 0. So that's an identity matrix, but I like the I matrix. And then what I did was I thought, what could we do very basically and geometrically with that? Nothing too hard. Let me slide this off to the side. There we go. And I've just left my script. And that is the right one right there. I think that's the one, or that could be the wrong one. There it is. I'm just going to try and grab here. You see that I have a little bit of control over that, starting with a rectangle, breaking it up, culling out, so I'm only dealing with 4 points, lifting those points according to the data coming out to the I matrix, and then that I array will drive it back into being interpolated, which you get this beautiful form here, and this is really the geometry that does all the jazz. And if I can stay from bouncing out of this, you see you get a sense of that identity array a little better here. So you bring it down to nothing at -4, and then you bring it all the way up to +4 over here. So erase it from one side to the next. So think about it as a very powerful piece of equipment to draw that out, and then have that control over what you want to kind of build architecturally. And then I'm just putting that back into an array to give a nice pattern, array, box array, as it was called, rectangular array, and I'm using meshes to make it move pretty fast. You could use subdivision to make it smoother. You could use pipe, variable pipe, and all this stuff to slow it down, but I think that's enough. I'm just capping and joining it, even though I don't even need if I need to know that. But take a look at the speed at which these scripts are running. It's pretty nice, just dealing with that data that you have complete control over changing that geometry. So you can move it all very quickly and numerically outside of Grasshopper in Visual Studio Code to end up with your original pieces, and then bring it back through the other side. And the pipes kind of break on 4, but they work well if it's just a single unit. So that's one piece of data visualization. I'm going to take that one off. I'm going to put on, leave this one, and I want to take that one off and put on this one, which is a big jivey one. And this is a big tubular one, which I thought was kind of fun. Here it is, and I guess we can bring it back over to seeing it in both scenarios, top, side, whatever you want. There's the pattern on top, there's the front, and there's the side view of it. And there's our wonderful, let me see if I can pull this back to rendered. There you go. These kind of strange forms that have been looped up. And that's a data visualization that I think I did down here, which was driving from an array that you can change up whenever you want. So if I get rid of this function and go to my data visualization down here, you've got this little guy that's doing all the do-si-do right here. And we can bring him in here to see what he does. He's probably going to get pretty large and pretty small, so we'll just put him in to the middle. And that's enough to start. That's a pretty simple geometry deriving from an array that I'm simply grafting points. I'm pulling out the points and I'm grafting them in this position. And with those, I'm taking those points and I'm dispatching them and putting one circle in here and a second circle in here and doing a region union. So I get this little dimple and lip. And I'm driving that by the radius of my addition of two numerical arrays. And then I'm also multiplying and using subtraction arrays and organizing my data to lift it up into this pattern. So I'm using the same array, addition, multiplication, subtraction. I didn't use division for anything, and I'm lofting those together, and the sort makes that possible. So if we have that shape and we decide we want to go back to the original and we want to randomize, we're going to randomize that shape and get this other form. So you're moving very fast with the gene pool to produce different arrays. And that's basically that one, so it's not that fancy. Let me pull this one in. Let me leave this one. Here's the next one, which is kind of funky as well. You see that that does some weird stuff. It's just kind of nice. What was I doing with that one? I was generating this form. So we can take these guys off. Take a look at this middle one. It's kind of funky, being done by the array. But what am I using? Well, I'm using the sine, cosine, and rounding functions of this exact same similar array. So if I write back in there and I want to randomize that pattern, then it has to update to that. I think there's a little sort in there. You get these really weird vessels. We've got a really low number here. So if I want to bring that out, should be able to thicken that bottom and make it look a little more funky. And if you're looking for funk, this is the way to do it. So I'm going to pull out the points down here. I'm going to pull out the other points here. I'm going to make a circle here and a circle here. And I really like those unions, that I get these really nice shapes. And then I'm lifting them through a list length, and I'm using a series to pull them through as a list count, which is the list count of what's there. And I'm just moving them up, and you can see those wonderful patterns as they go. And it's great for robotics if you were printing and you wanted to have this as a tool path and you wanted to get some funky forms. They're all planar, and there you go. You get this nice little vessel. You can cap it, you can thicken it, you can shell it, and do whatever you have in Rhino. But this is for people that want to get a little funky with this geometry. So I'm leaving the last one here, which was playing off greater than function, less than function, logical function. And what I was looking at it as is Boolean conditionals and logical functions to call out information. So I'm going to leave that for you to experiment with what that data visualization might look like. And I'll just leave that blank and put it over to color, and we'll leave it on kind of an off purple, light purple. So you might be tempted to do something with it. So that's kind of blank. So I'm just going to end that now, save. Put back up my three crazy objects that are here. And actually, I think I'll leave that last one because I kind of like that last one. And that's a little weird form that you can think about doing in different ways with a pretty fast mesh. You don't really have to bother with the mesh. You could probably leave that off. Leave that off. Go here for the geometry and deal with this nice fast geometry here. And see what you can do with it. Play around with it. Understand that that's numerically controlled through functions that are happening back here in exciting Visual Studio Code with Numpy. And that's the point of what I'm trying to figure out. And I'm trying to just get more complex as we go, but keep things simple to start, because you want to have everything up and running and making sense for you. And you want to push Numpy basics, array, and vectorized computations into Grasshopper so you can speed up and get total control of your data trees. Think about them in a totally different way. This is script 2.0, which is now available at wickersonstudios.com. And I'm going to go in and I'm going to get to work on I just have to make video tutorials or a summary video tutorial and some visualization for the next set, which is the AI Copilot, the AI Stable Diffusion. I also am doing some really cool stuff with these renders out, and you can see them on Facebook and Instagram, LinkedIn, and you can see what I'm doing with Stable Diffusion with these simple models. It's pretty incredible. All right, so we'll stop recording.